Hello and welcome guys to Get channel. Today we are going to discuss about problems on normal forms. So this is a problem solving session. So I recommend you to watch my previous lecture before watching this lecture because this lecture is full of problems. I won't explain all the concepts in this lecture. Now I'm going to this problem. Relation R has 8 attributes A, B, C, D, F, G, H, and this is the functional dependence set is given for that relation. R is in which normal form? This is the question. This question is asked in GATE 2013 for 2 marks. This is a very important question. Look at it now. Now, the functional dependencies are given. Which normal form they are asking? If they are given like this, you have to believe that it is already in 1NF first of all. First step, you have to believe it is already in 1NF. And next step, you need to check whether it is in 2NF or not. Now, I am checking whether it is in 2NF or not. For 2NF, what we need to do? We need to find the candidate case. For candidate keys, there is a method. You see this. What are the functional dependencies? What are the attributes there? A, B, C, D, E, F, G, H. Look at the right hand side of the functional dependencies. A is there, E is there, C is there, F is there. I am cutting F here. H is there, cut F also, H also. B is there, cut B also. G is there, so cut G also. D is not there. So D can't be derived from any of the attributes. That means, so you should include D in the candidate key. One attribute of candidate key, we got it. D should be included. Now with the, what should be included? So that if you do the closure, we'll get the all attributes. I am taking for example A. I am taking AD closure. You know how to do closure? I am writing directly. With AD closure, we can get A, we can get D. With A, we can get BC. With A, we can derive BC. Na? So, I am writing BC here. With B, we can get CFH. So, C is there. FH I am including. With E, we can get A. E is not there. With F, we can get E. You look at here. This with F, we can get E. So, I am writing E here. With E, we can get A. With E, we can derive A. Na? So, I am writing A here. Now, observe this one. We got all the functional attributes. 1, 2, 3, 4, 5, 6, 7, 8 attributes. We have got it. 8 attributes is the number of attributes. So, AD is candidate key. Like that, if you want to check how many candidate keys are there, follow this approach. D should be anyhow should be included. We are taking A. A we can derive through E now. With E we can derive A. So if AD closure is there, so EA closure will ED closure will also be there. Because if you do ED closure, ED will be included. With E you can get A. So ED closure is obviously the closure of AD only. So these two will be there. Now E, how can you derive E? With F. With F, you can derive E. So, F, E closure. Also, FE is a candidate key with F. So, how can you derive F? With, if you have B, you can derive F now. So, BE closure. Also gives you all the attributes like AD. This is very important approach. Because in exam, if you solve every single thing, it will take a lot of time. Rather than solving, you just follow this approach. A we can derive through E, E we can derive through F. I have to write D here. And F I have written B now, I have written B, D here. 1 minute. Here FD closure and BD closure like this. With A we can derive through E, E we can derive through F, F we can derive through B. So how many candidate keys are there? I am writing it here. Number of candidate keys. How many candidate keys are there? AD is a candidate key and ED is the candidate key. FD is a candidate key. BD is a candidate key. So what are primary attributes? I have told you how to calculate primary attributes in my previous lectures. You can look at that one. What are the primary attributes? A, D, E, F, B. Other than primary attributes, which attributes are present? They are non-primary attributes. Now I am writing non-primary attributes. What are non-prime attributes? So the attribute which are other than ADE. So B is non-prime attribute. B is there na, so not B. C is non-prime attribute. E, F, G is non-prime attribute. H is non-prime attribute. Now we got primary attributes, we got non-primary attributes. Now we should check for 2NF functional dependency, true or not. For 2NF, you look at here, there should be no partial dependency. For 2NF, there should be no partial dependency. Means what is partial dependency? Now note it up till now. Now we are going to do next step. We are checking for 2NF functional dependency now. Now look at here. For 2NF, there should be no partial dependency. No? For 2NF, there should be no partial dependency. What is partial dependency? If any non-prime attribute is functionally dependent on prime attribute. This is partial dependency. So in 2NF, this should not be there. Now I'm looking at here. This is a, what is this? This F is a prime attribute. This E is a prime attribute. So this is not a problem. What is this? This is E. E is a prime attribute. A is also a prime attribute. So these two are not a problem for us. Now I am doing this one. We can split this one into three parts. This is, I am applying decomposition rule here. B to C, B to F, B to G, B to H. What this B is primary attribute. What about C? C is non-primary. You look at here. B is prime. B is primary attribute and C is non-prime attribute. So this is partial dependency. In our functional dependency, there should not be partial dependency, but we can say that here there is partial dependency. So this relation is not in 2NF. So we need not have to check for 3NF, 4NF, 5NF. These are all not required. If it is not in 2NF, then it is not in 3NF also. So this functional dependency is not in 2NF. This is very important. In which normal form is it there currently now? Means it is there in 1NF. That means I already told you, assume it to be 1NF if they have not given anything about the question. So this is there in 1NF. Look like this, you have to solve this question. And you have solved a GATE 2013 question. This is of 2 marks. Like this, you should solve the question. Note it down. Look at this question. This question is asked in GATE 2022 for 1 mark. This is a MCQ type question. Observe this one. A relation database model which is true. Which one is true? Now look at option A. A relation with only 2 attributes is given in B, is always in BCNF, and BCD are something they are given. Now first I am checking with A. A relation with only 2 attributes is always in BCNF. Now I am taking an example for this one. Let R is a relation, PQ are the attributes with only 2 attributes. What can be the functional dependency you can expect from this relation? P to Q is the only functional dependency you can expect from this relation. Or else Q to P also could be there. For BCNF, what I have told you? For BCNF, what I have told you? PQ should be super case. Then in this case, they are obviously super keys only. If you do P closure, you can get Q. If you do Q closure, also you can get P. So P and Q are super keys in this case. So I am writing it here. PQ are super keys. So option A is true. They will be obviously in BCNF. So this is correct. Now I am checking the B option. If all attributes of a relation are prime attributes, all attributes are prime attributes, then the relation is in BCNF. We can't say Now you check why we can say that or not. Prime attributes means what? Means all the attributes of prime attributes means we can get all the candidate keys from our respective prime attributes. Let us take an example for this one. I am taking R as a relation. A comma B comma C are there as the attributes now. A B to C will be there, and we can get C to A also if this is the case. If this is the case, what is the AB closure? We can get ABC. So AB is candidate key. What is CB closure? We can get ABC here also. But if you look at this one, C is not a super key. With C alone, we can derive all the attributes. So this violates not in BCNF. So this functional dependency violates BCNF. So option B is wrong. You can say that one. Now coming to C, every relation has at least one non-prime attribute. I took here those two examples, all attributes are prime attributes. So B is wrong. If B is wrong, that means C is wrong. Now checking with D, BCNF decompositions preserve functional dependencies. We know BCNF decompositions will not preserve functional dependencies, because when the table is divided into two tables, we can't say that the functional dependency is preserved. Now note it down. That's all for today's lecture. Thank you for watching this lecture.